what I'd like to do this morning with you is I set out to convince you of two important things. One of these was to prove to you that the quantity of non-certified sprinklers in the world today, not just in Brazil, is increasing at a rapid rate. But I think, thanks to Felipe de Mello, you're already convinced. You saw the statistics for Brazil. I'm going to show you some more statistics for the rest of the world. But the second point that I wanted to show you during my presentation is that these non-certified sprinklers pose a real threat to the protection of buildings and lives in wherever they're installed. And that's simply because they don't work the way we expect sprinklers to work. Before I start, for those of you who are not familiar with the International Fire Sprinkler Association, or IFSA, we are a non-profit trade industry association that works to promote and enhance the business of manufacturing and installing sprinkler systems to protect buildings all over the world against fire. And we are active basically in four different but important areas. One of the first areas is that we try to kickstart the founding of local sprinkler trade industry associations like CBSpk. And we do that because we feel that the best way to spread the message about how great fire sprinkler systems are is to do it on a local level. We develop information systems to protect product integrity and industry identity. We deliver training and education, and we are also very active in ensuring that sprinklers are included in legislation and building codes in the different countries around the world. So I invite you to come and visit us on www.firesprinkler.global. Now, our story today doesn't start here in Brazil, nor does it end here, but as you will learn, as Felipe de Mello explained, your wonderful country played a very important role in its telling. Without the help of a lot of people in this room, we would have never gotten to where we are today. The question that I want to ask you is the same question that I asked the audience back in February of this year at the Fire Sprinkler Americas conference in Medellin, Colombia. And that is, when does a non-certified sprinkler, which is shown in the picture on the left, can we say it's equivalent to a certified sprinkler, which is shown on the right? Or in other words, when is a fire sprinkler really a fire sprinkler? Now, we're fortunate today because most of the people in our audience is familiar with what a fire sprinkler is and exactly how a fire sprinkler system is supposed to operate. But we have to be honest with ourselves, because the rest of the people in this hotel, the general public, they have no idea about what a fire sprinkler is and what a fire sprinkler system is supposed to do. That puts a heavy burden on our shoulders. We have a responsibility to protect these people against unfriendly fire, and we also have a responsibility, all of us, to protect this wonderful industry that we work in. And it is a fantastic industry with a history that stretches over 100 years. And we know, all of us in this room, that real fire sprinkler systems can do wonderful things. They are 95% or more effective at extinguishing or controlling fires. There's less than a 1 in 14 million chance that a sprinkler will activate in the absence of fire. We know that when a fire occurs in an occupancy that's protected by a sprinkler system, the damage due to fire is going to be 8 times or more less in that occupancy than if the fire would have occurred in a building without a sprinkler system. We've developed sprinklers today that can help people trapped in the room of fire origin actually survive the fire. And of course, more than 90% of all the fires that occur in sprinklered buildings are controlled or extinguished by 4 sprinklers or less. So if I go back and I ask that same question again, what's the difference between the sprinkler on the left and the sprinkler on the right? You have to take a close look at those little marks that are stamped on the deflector of a certified sprinkler. It's those small certification marks that mean big things. Organizations that we've all heard of, like FM Approvals, Underwriters Laboratories, VDS in Germany, LPCB. These are your assurance that the sprinkler will perform as you expect it to. Now, when I started in this business 25 years ago, it was virtually unheard of for a company to make sprinklers that were uncertified. It just didn't happen. We didn't think about it at all. But the situation has changed incredibly and very quickly in the last few years. Felipe de Mello showed you statistics about Brazil. If we look at the world market, now this is data, it's a little bit dated, but was collected by the International Fire Sprinkler Association by talking to industry experts in countries around the world. And we're looking at data of sprinkler shipments and installations outside of North America. What you see is that in 2001, the global sprinkler market was about 26 million outside of North America, and about 30% or 10 million of those sprinklers were non-certified sprinklers. Already by 2007, that market had increased tremendously to almost 70 million, but of course, so had the amount of non-certified sprinklers to over 30 million, or more than 50%. So, on the good side, the world sprinkler market is growing. That's a step forward. But the amount of non-certified sprinklers that are being installed now is growing disproportionately faster, and that is a giant step backwards. Let's take a look. I'm going to save us a little time. I have some data on Brazil. Thank goodness Felipe was able to go into a lot more detail. If we look at another fast-growing economy, that's India, on the right-hand side, we see that just between the years of 2011 and 2013, the quantity of non-certified sprinklers grew by a factor of six times. And this information about India was provided from FM Global. So hopefully, thanks to Felipe, thanks to some of these statistics, I've been able to convince you that non-certified sprinklers being installed in the world is growing at a rapidly alarming rate. Why is that important? Why should we be worried about that? And that's what I'd like to talk about now. 2 years ago, we were sitting at an International Fire Sprinkler Association board meeting, and Underwriters Laboratories sits on that board, and they talked about a situation where a large multinational company was building several warehouses in China. And together with their insurance company, they specified that these warehouses needed to be protected by a type of sprinkler called an ESFR sprinkler. And probably a lot of you know what an ESFR sprinkler is. It has a very large orifice. It sends a lot of water at a very high pressure down to penetrate the fire plume that can occur in the racks in a large warehouse. Warehouses were built. The multinational, the owner, together with its insurer, they went to inspect these buildings. And when they looked at the ceiling, they noticed that the ESFR sprinklers that were installed in those buildings had no certification marks, and that brought them back to UL. And they asked UL the question, will these sprinklers protect our properties? Now, if you look at the pictures, again, similar to the picture I showed earlier, even for us, it's quite hard to tell the difference between the non-certified sprinkler on the left and the listed and approved sprinkler on the right. So you can imagine, if you know nothing about sprinkler systems, it's virtually impossible to tell the difference. And this gave the IFSA an idea. Using sprinklers from these warehouses, we commissioned UL to answer that question. Will these sprinklers protect these warehouses? Now, in this actual situation, we had relatively small sample sizes. So I'm going to come back to this slide. So we asked UL to submit these sprinklers to their testing standard UL 1767. Because we had a small sample size, we were not able to run all of the more than 35 plus tests that are involved in listing and approving ESFR sprinklers. We were only able to do 9 of the tests, and I wanted to share with you some of those results. Now, a lot of us don't work in laboratories and write reports, but I think you don't have to be a technical genius to see what's wrong in this picture. Okay? This is a very simple test. We're just taking the sprinkler, opening it up, and we're running water at the maximum pressure through that frame to see if it has an effect on the deflector. As you can see, it had a very serious effect. It deformed that deflector, which means that no longer is the water being directed straight down on the fire plume. On the sprinkler on the left, the water is going somewhere else, not where we expect it to go. The next tests were operation tests. And here we just look, we submit the sprinkler to temperature, and we expose it to heat and look at its behavior. Well, in the samples that were tested, again, we had actually 2 types of ESFR sprinklers from these warehouses. In the samples that were tested, many of the sprinklers opened very late, and some of them didn't open at all. And in a vast majority, an incident called lodgement occurred. When a fire sprinkler activates, we want all the pieces that are in that response assembly to fly clear of the sprinkler so that the water has a direct path on the deflector. When those pieces get stuck somewhere on the frame, on the deflector, changes the way that the water is distributed. In this case, because of these lodgements that occurred, we had a large proportion of the water actually directed back up towards the ceiling rather than down towards the fire. The next topic I want to talk about, which I'm going to get even more passionate about a little bit later, is the topic of O-rings that were taken out of these warehouses. They had O-rings, and O-rings are great in certain devices in that they eliminate leaks, but in fire sprinklers, they cause a very large problem in that many cases the sprinklers never open. And again, when we get to the sprinklers that were taken out of the 2 high-rise buildings in Sao Paulo, I'm going to talk a little bit more about O-rings. Finally, the key part of any approval or listing for an ESFR sprinkler is the full battery of full-scale fire tests. All ESFR sprinklers that are listed or approved have to undergo full-scale fire tests in challenging conditions in order to obtain an FM approval or UL listing. Needless to say, we did not subject these sprinklers to those full-scale fire tests but it's obvious that they would have done a terrible job controlling the fire. As a result, UL published their report, and the report conclusively shows that these non-certified devices, I will call them, don't even deserve to be called sprinklers. They failed 7 out of the 9 tests that were performed, and simply stated, a warehouse that has these devices at the ceiling in the event of a fire will burn to the ground. Now that report is of course going to be of interest to the end user, to the business. That report is going to be of interest to the insurance companies. But at the IFSA, we ask ourselves the question, okay, non-certified sprinklers, they don't protect buildings. What about people? Do non-certified sprinklers also pose a threat to human life in the event of a fire? At the International Fire Sprinkler Association, we believed that that was a clear danger. But of course, it had to be proven. And this is where Brazil comes into the picture, CBSpk, and helps us to prove this fact. Felipe explained 2 high-rise buildings in Sao Paulo were selected, and this time hundreds of sprinklers were removed. They were all control mode sprinklers from 2 different kinds of occupancies, again, from the offices up above and from the garage down below. The entire process of removal was very carefully controlled. Extreme care was taken when we removed these sprinklers so that they were not damaged. Each sprinkler was carefully wrapped and protected and sent to the labs, underwriters, laboratories, and Factory Mutual for further analysis. When the sprinklers arrived at both FM approvals and underwriters' laboratories, they were, of course, carefully unpackaged, and at FM, they were submitted to FM Approval Standard 2000, which is their approval standard for control mode sprinklers, and at UL, they were subjected to tests included in UL 199. Now these 2 tests, or these 2 standards, again, include a whole variety of tests which really form the basis for all recognized sprinkler testing around the world. The first observation that was made by both labs on these control mode sprinklers, as was seen when UL tested the ESFR sprinklers, is that 100% of these sprinklers had O-rings in them. O-rings, I hope the translators can get this, are bad, bad, bad. They've been banned in the US for almost 15 years. They are still the subject of ongoing product recalls in the US. The problem with O-rings is, as I mentioned earlier, they do a fantastic job of sealing, but with time, they degrade and they stick to the seat of the sprinkler, which means that excess pressures are required in order to operate that sprinkler. And when the excess pressure that's required is higher than what the sprinkler system can deliver, that sprinkler will never open at all. If you find a sprinkler in a building with an O-ring in it, you can be sure that that sprinkler has never been subjected to an independent third-party recognized approval authority. Cause other problems. They're sticky. They're rubbery. So when a sprinkler operates and it has an O-ring in it, there's a higher probability that it will get stuck, as we see in this picture on the left, in the waterway of the sprinkler. And now the water that's coming out of the sprinkler is going in all different directions except where we want it to go. Testing for lodgements, probably the folks from Scope will agree with me, is the nightmare of any sprinkler designer. These are very often the most difficult tests to pass at underwriters' laboratories and at FM approvals. Here's how they do it. They look, first of all, at the ways water can come into that sprinkler. So if it's on a branch line, it's coming from both directions. If it's sitting at the bottom of a drop, it's coming from one direction. Then they operate that sprinkler at a whole wide range of pressures, from a half a bar all the way up to 12 bar. Now, in the samples that were removed from the two high-rise buildings in Sao Paulo, both UL and FM came up with a failure rate of about 47%. That means that 1 out of every 2 of those sprinklers got something caught when they operated. So the question is, in order for a sprinkler to pass UL or FM, does anybody know what the failure rate allowed by UL and FM for the lodgement test is? So UL and FM, the maximum percentage of lodgement is less than 1%. That means that those sprinklers in those two high-rise buildings had 50 times higher probability of lodgement than what is allowed when a sprinkler is UL or FM approved. What happens, again, when lodgement occurs? Well, and this is sort of a difficult picture to see, but what we're showing here is 6 sprinklers going off at the same time. And if we take that 50% lodgement ratio, that means we've put here 3 sprinklers that, out of the 6 that have lodgement. What you see in the picture is a lot of dark areas, and you see water being sprayed in directions that you would not normally see. This is exactly what happens in a lodgement situation. The water simply is going in unpredictable directions, and we have no idea the effect that it's going to have on the fire below. Another test that we run is what's called the response time index of the sprinkler. Now, when we take, and it's a measure of how fast that sprinkler is going to operate. When you combine the RTI, or response time index, with the conductivity of the sprinkler and with its activation temperature, it gives you an idea of how quickly it will operate in a fire conditions. And in most cases, the faster the RTI of a sprinkler is, the better, because obviously our sprinkler is opening faster and we're getting water in the very early stages of that fire growth curve. But in some cases, if our sprinkler is too fast, we can get too many sprinklers opening at the same time. And when we have too many sprinklers going on at the same time, our pump and our water supply can't keep up, and the fire can actually overwhelm the sprinkler system. What was interesting in the sprinklers that were taken out of these two high-rise buildings was that on first appearance, they look like standard response sprinklers. And all the installation standards tell you how to design for standard response sprinklers. But when both UL and FM ran the RTI tests, they actually found out that the glass bulbs had a faster RTI than standard response sprinklers, which made them special response sprinklers. Now, This is a really interesting question, because when you get a sprinkler approved as a special response sprinkler, you're required to put special marks on it so that people can tell the difference between a special response and a standard response. Of course, these sprinklers didn't have any markings at all. What's also interesting, and I can't answer this question, but probably everyone in the room can, when you look at NFPA, NFPA does not have any guidance on how to use special response sprinklers. In the European installation rules, they do. They tell you where and when you can use special response sprinklers. I don't know about the Brazilian rules, but I'm guessing that there's no guidance in there on how to use special response sprinklers. So that's my main question for the designers and the installers that installed these sprinklers in these two buildings. Did they even know that they were special response sprinklers? The next test that was run is the assembly load test. When we build a sprinkler, we have a compressive load on the valve of the sprinkler holding the water back. It keeps that valve, that sprinkler, closed. When the bulb breaks, the sprinkler opens. If we have too little compression load on that glass bulb, that means we're going to have a leaky sprinkler. But if we have too much load on the glass bulb, glass is a very unforgiving substance. There's a possibility, especially in the case of a water hammer or when the fire pump starts up, that glass bulb could break. And then we have an activation in the absence of fire, which is a bad thing. Well, in the samples that were tested by both UL and FM, the assembly load on the glass bulb was higher than what is allowed. So there was a higher than normal compressive force on that glass bulb. And the reason why, again, I find this interesting is because the amount of the compressive load on that glass bulb was okay if that glass bulb would have been a standard response glass bulb. But as I said a little bit earlier, it wasn't. It was a special response glass bulb with a thinner glass. And so I even asked the question, did the company that manufactured these sprinklers even know that they had special response glass bulbs when they were making these sprinklers? We don't think of sprinklers as being highly engineered, precise devices, but in fact they are. And as manufacturers are always trying to improve their performance, sprinklers become more and more fragile. If you think about the supply chain from the factory to the ceiling in a finished building, along that path, there's a very high risk for damage on the job site, during transportation, and the approval labs have taken this into account. They submit any approved or listed sprinkler to what they call a rough usage test. And basically that test tries to reproduce the kind of bumps and bangs that a sprinkler could experience on that path. Now, in order to pass these tests at the labs, listed and approved manufacturers provide protection for each individual sprinkler, whether it's a cap or a clip or a strap. We know for a fact that these sprinklers that were installed in these buildings never came with that kind of protection. So it's obvious that when UL and FM subjected these sprinklers to these rough usage tests, they didn't have protection and they were damaged. We had bent deflectors, we had damaged glass bulbs. A damaged glass bulb could lead to an activation in the absence of fire. For ESFR sprinklers, I stressed exactly how important the full-scale fire test is. For standard control mode sprinklers, we don't do any full-scale fire testing anymore, but we do individual distribution tests where we have an open sprinkler at the ceiling and we spray water out of it and collect it in equally spaced pans underneath. The way that water is distributed has to meet the requirements of the labs. And whereas the pendant sprinklers that were submitted to UL, they pass the distribution test. All of the upright sprinklers pass the test. All of the pendant sprinklers, whether it was at UL or FM, failed the distribution test. Now, whereas we don't do full-scale fire testing anymore on control mode sprinklers, UL does what they call a wood crib fire test. And what we do is, when we run this test, there's a constant burning gas flame underneath a wood pallet, and we measure how much wood burns over during the 30-minute test, and we also look at ceiling temperatures. What we found when UL tested these sprinklers to the wood crib fire test, that they failed the test because they were unable to limit ceiling temperatures to less than 326 degrees Celsius. Hopefully, I've achieved my objective, which is to convince you that non-certified sprinklers are being found more and more throughout the world, and that because of all these weaknesses, they are a real risk. My job today has been very easy because I have an audience here who knows what sprinkler systems are and cares about them. The IFSA is committed to taking this data, which now exists in report format, and turning it into a media campaign. We have set aside significant funds to allow the production of media tools like videos, like technical articles, speeches at conferences. We are committed to making that investment, but we can't do it alone, and this is where you come in. It's easy for me to convince a room of people who already know what sprinkler systems are about, but we need your support to help us spread the message throughout the country of Brazil.